Hey everyone, Mr. Hauk here. In today's video, we're going to be exploring the first quadrant of the unit circle. By the end of this lesson, we should be able to use special right triangles to construct the first quadrant of the unit circle. So let's ask ourselves, what is this unit circle? Well, the unit circle is the circle with radius 1 centered at the origin. In the xy coordinate plane, the unit circle is the set of points xy such that the equation x squared plus y squared equals 1 is satisfied. So with this little bit of information about the unit circle, let's see if we can find all points on the unit circle whose first coordinate is equal to 2/3. Well, when we're talking about the first coordinate in an ordered pair is x. Okay, x is the first coordinate in an ordered pair. So we want to know what all points on the unit circle have an x coordinate equal to 2/3. Well, let's take that equation x squared plus y squared equals 1, and let's go ahead and substitute x with 2/3. So we have 2/3 squared plus y squared equals 1. Well, if we square 2/3, we're going to get 4/9. So this tells us that y squared is equal to 1, and we'll go ahead and subtract the 4/9 to the other side, and that's going to be equal to 5/9. Well, we know that by taking the square root of both sides, we can remove the power of 2 from the y, so this also implies that y is equal to the positive and negative square root of 5 divided by 3. So what that tells us is one of the points would be 2/3, comma, positive 5/3, and another point on the unit circle with the x coordinate of 2/3 would be 2/3 and negative square root of 5/3. And that little symbol there with the three dots in a triangle form means therefore, just in case you haven't seen that before. All right. So let's consider some special right triangles here as we continue to explore this unit circle. So I'm going to give us some space here to work. And in our first example, we have a 30, 60, 90 right triangle. And let's go ahead and call this leg x. Let's call this leg y. So if I were to take the cosine of 30 degrees, well, that would be equal to the adjacent leg x divided by 1. And simplifying the cosine of 30 degrees, because if you type in a Desmos or your calculator, you're going to get a decimal. But the exact answer would be that x is equal to the square root of 3/2. If I were to take the sine of 30 degrees, well, that'd be equal to the opposite leg, which is y, divided by 1. And if you use the calculator to do the sine of 30 degrees, that would tell us that y is equal to 1/2. Okay, so we're going to keep these values in mind for coming up soon. In our second special right triangle, we have a 45, 45, 90 right triangle. Let's go ahead and call this bottom leg x. We'll call the horizontal leg y. And using the same process, let's go ahead and calculate the cosine of x. So the cosine of x would be the adjacent leg, which is x, or sorry, the cosine of 45 degrees, not x. So cosine of 45 degrees would be equal to the adjacent leg x divided by 1. And if you plug that in and get the exact answer for that decimal, that would tell us actually that x is square root of 2 divided by 2. And if we took the sine of 45 degrees, that would be the opposite leg y divided by the hypotenuse 1, which would also be the square root of 2 divided by 2. All right. And then next, let's consider this third triangle, which is a 30, 60, 90 triangle. Again, let's call this leg x, let's call this leg y. And if I were to take the cosine of 60 degrees, well, the cosine of 60 degrees would be the adjacent leg x divided by 1, which would tell us that x is equal to 1/2 after simplifying. And if we were to take the sine of 60 degrees, that would be the opposite leg y divided by the hypotenuse 1. And after getting an exact answer, that would be y is equal to square root of 3/2. All right, so it actually turns out that these three triangles are very special to the unit circle, because what I could actually do is I could fit these three triangles into quadrant 1. And notice that these three triangles each have points that fall on the exterior of the unit circle, right here. So this was one of our triangles. This was our 45, 45, 90 triangle. And this was another one of our 30, 60, 90 triangles. And what this allows us to do is come up with some very special points in the first quadrant of the unit circle. So taking all those triangles and writing the special points here, this is what we would get. So in our first triangle, we had a 30, 60, 90 triangle, and the angle that we used was 30 degrees. If we converted 30 degrees to radians, we would have pi over 6 radians. So we have 30 degrees and pi over 6 radians, and the ordered pair that we got was square root of 3 over 2 for the x value, and we got 1/2 for the y value. And again, this is a good time to note that the x value is the cosine of theta, and that the y value of an ordered pair is the sine of theta. So an ordered pair xy would be the cosine of theta, comma, the sine of theta, theta being that angle. So a 30-degree angle would give us a cosine of root 3 over 2 and a sine of 1/2. The 45, 45, 90 triangle was this triangle right here, and if we converted 45 degrees to radians, we would get pi over 4 radians. Okay? And the cosine of 45 degrees, which would be our x value, was square root of 2 over 2. And the sine of 45 degrees, which would be our y value, was also square root of 2 over 2. And then lastly, we had our another 30, 60, 90 triangle, and the angle that we were looking at in the special right triangles was the 60-degree angle, which if we converted 60 degrees to radians, we would get pi over 3. The cosine of 60 degrees, as we saw in the previous page of our notes, was 1/2, so that's our x value. And the sine of 60 degrees gave us square root 3 over 2, which would be our y value here. Now, there are some other important points that we want to take note of. If we look at the x-axis, well, this would represent a triangle. Well, this would really represent 0 degrees. And 0 degrees converted to radians would be 0 radians. And the point on the circle would correspond to the point 1, 0. Also, if we had a 90-degree triangle, this would correspond to the y-axis. 90 degrees converted into radians would be pi over 2 radians. And the point that would fall on the circle would have the coordinates 0, 1. Okay? So this is the first quadrant of the unit circle, and these are all very important points that we're going to be using several times throughout the year. It would be in your best interest to go ahead and memorize them. It may turn out that as many times as we use these points, that you will probably have at least the first quadrant of the unit circle memorized, but this is how we derive and construct the first quadrant of the unit circle. So let's use this quadrant to answer a couple of questions. Here in question 1, our practice problems, we want to know what is the cosine of 45 degrees. Well, remember that the cosine of an angle, so the cosine of an angle theta, is equal to the x value of that ordered pair. So if I look at 45 degrees, well, the x value of 45 degrees is square root of 2 over 2. So that tells us that the cosine of 45 degrees is equal to square root of 2 over 2. Don't like that, it looks ugly. Let's do that again. Square root of 2 over 2, good. And again, that's right here. We have our 45-degree angle. The x value of this ordered pair on the unit circle at 45 degrees is square root of 2 over 2. Now let's find the sine of pi over 3. Well, recall that the sine of an angle is the y value of that ordered pair. So if I wanted to find the sine of 45 degrees, I would go to 45 degrees on my unit circle, or sorry, not 45 degrees, mix that up, that should be pi over 3. The sine of pi over 3. So let's go to the angle pi given by pi over 3 radians. So pi over 3 radians is right here. And the sine of pi over 3, the y value, will be square root 3 over 2. So the sine of pi over 3 would be the square root of 3 over 2. All right, in our third practice problem, we want to know for what angle theta in the first quadrant is the sine of theta equal to 1/2. So what this is really asking us, I'm going to rewrite the problem. This is really asking, let's get shape recognition off. So this is really asking us which angle theta has a y value or a y coordinate of 1/2. So if we go up to our unit circle, we want to find which angle has a y coordinate of 1/2. Well, here I see a y coordinate of 1/2, and that corresponds to a 30-degree angle or a pi over 6, or an angle of pi over 6 radians. So we would say 30 degrees or pi over 6 radians. Okay, and then in our last practice problem for these notes, we are asked for what angle theta in the first quadrant is the cosine of theta equal to square root of 3 over 2. So once again, let's go ahead and rewrite this question. This is really asking us, which angle has an x coordinate of square root of 3 over 2. Which angle has an x coordinate of square root of 3 over 2. Well, if we look up at our unit circle, let's look at our x coordinates. Well, square root of 3 over 2 is right here for an x coordinate. And once again, that corresponds to a 30-degree angle or an angle with pi over 6 radians. Okay, so again, 30 degrees or pi over 6 radians.